In this session, we will be dealing with the problems of the response of RL circuits to various functions. Here is a question. At t is equal to 0, unit impulse voltage of unit width is applied to a series RL circuit as shown in the figure. Obtain an expression for I of t. Okay. So here we have the specialty. The difference for this problem is that here we have input as a function of time. It is some function, and that function is given here. It is a unit impulse function with a unit width. Okay, that is time is 1 and amplitude is 1. So I hope you know how to represent this signal. How can we represent this signal? This u of t. This signal is u of t minus u of t minus 1. That is, how will we get this signal? This signal, you know what is u of t. This is u of t, that is starting from 0 and ending to infinity. That is the signal u of t. What is u of t minus 1? T minus 1, u of t minus 1 means it is a signal which starts from 1. That is, this signal is shifted to left by 1 unit and extends till infinity. And that is u of t minus 1. Okay, so u of t minus u of t minus 1. See, if we subtract this signal from this signal, what will we get? The result in this? This. Okay, that is our question. That is u of t. We can represent this as u of t minus u of t minus 1. This is the signal. First of all, we have to understand the input signal. Okay, so now we have understood the input signal. So now we can write v of t is equal to u of t minus u of t minus 1. Here we have to transform this circuit into S domain. Okay, only then we can find the expression for I of t. After transform the circuit into S domain, then find I of S and then go for I of t. These are the steps for these type of problems. Okay, so now we have to go for B of S. What is B of S? The Laplace transform of this function. What is the Laplace transform of u of t? Laplace transform of u of t is 1 by s. What is Laplace transform of? If you know the Laplace transform is f of s. What is by time shifting theorem? Here is the time shifting theorem. If Laplace transform of f of t is f of s, then Laplace transform of f of t minus a is e raised to minus a is into f of s. Here we have a as 1. So we can write e raised to minus 1 s, that is e raised to minus s by s. Okay, so here we have 1 minus e raised to minus s by s is the Laplace transform of this function. So why did we find this Laplace transform? We have to transform the circuit into S domain. That is, the circuit to be transformed into S domain. So we have the switch is closed. The question is asked at t is equal to 0, a unit impulse width is applied. That is, before t is equal to 0, that is at t is equal to t minus 0 minus, there was no signal and the circuit was unenergized. At t is equal to 0, the circuit is closed. The switch is closed. So now we have the circuit. Here v of t will become v of s, r will become r, and inductor, there is no initial current, therefore it will remain L into S. What is R? R is 1 ohm and Ls is equal to 1 Henry, that is 1 S, that is S itself. So now we can go for I of S. We can find the equation for I of S by using KVL. We can write the KVL equation V of S minus R into I of S minus S into, R, for R it's 1. We'll write R and put the values there. Ls into IFS is equal to 0. So now we have to put the values of VFS. We will write IFS first. IFS is equal to VFS divided by R plus LS. Okay. So now we can put the values of each. VFS is equal to 1 plus e raised to minus s by s. 1 minus e raised to minus s by s. R is equal to 1 and Ls is equal to 1s. So now we have got IFS, and from this we have to find I of t. Here we can split the terms 1 by s into s plus 1 minus e raised to minus s by s into s plus 1. So if in the denominator s into s plus 1 comes, we can find you can see a general equation. Let's see, by doing partial fraction expansion, 1 by s into s plus 1 is equal to a by s plus b by s plus 1. So 1 is equal to a into s plus 1 plus b into s. So when s is equal to 0, we will get a is equal to 1, and when s is equal to minus 1, we will get b is equal to minus 1. Similarly, we will see for e raised to minus s by s into s plus 1 is equal to a by s plus b by s plus 1. So e raised to minus s is equal to a into s plus 1 plus b into s. So when s is equal to 0, we will have a is equal to e raised to minus s, and when s is equal to minus 1, we will have b is equal to minus e raised to minus s. So here we have the positive term of the numerator and the negative term of the numerator as a and b. See, here also we have positive of the numerator, negative of the numerator as a and b. Then the denominator is s into s plus 1. So if you by heart this will be a tip for your, it will be easier for you to solve when such denominators come. The positive of the numerator will be a, the negative of the numerator will be b. So we can split IFS as IFS is equal to 1 by s minus 1 by s plus 1 plus e raised to minus s by s minus e raised to minus s by s plus 1. It's easier to remember. Okay, so we have written it like this. Now we can write the inverse Laplace transform. This I of t is equal to L inverse of I of s is equal to inverse Laplace transform is 1 by s is equal to 1 itself. So here, since it is a u of t function, we can write it as u of t. Laplace transform of u of t is also 1 by s. So here we have 1 by s plus 1. Okay. Here we have frequency shifting theorem. That is, if f of t is equal, Laplace transform of f of t is equal to f of s, then the Laplace transform of e raised to minus at into f of t is equal to f of s plus a. That is frequency shifting theorem. Then the L inverse will be e raised to minus at into f of t, where a here is 1. So e raised to minus t into u of t. Okay. Next we have e raised to minus s by s. Next we have time shifting theorem. That is, if f of t is equal to f of s, f of t minus a is equal to e raised to minus as into f of s. Here we have e raised to minus 1s into f of s. Okay, so here we can write it as f of t minus a. 1 by s is u of t. So we can write it as 1 by t minus a. That is u of t minus 1. Okay. Next we have e raised to minus s and s plus 1 both together. Here we have e raised to minus s by s plus 1. So L inverse of 1 by s is u of t. L inverse of 1 by s plus 1, that is frequency shifting theorem. That is e raised to minus t into u of t. Next we have time shifting theorem to be applied. That is e raised to minus s by s plus 1. So we have f of t minus a. That is u of t minus of, you have to apply for t alone. T minus 1 into u of t minus 1. So this u of minus t minus 1 into u of t minus 1. So here we can take the common u of t into 1 minus e raised to minus t plus u of t minus 1 into 1 minus e raised to minus t minus 1. I think we missed a minus sign because it is minus here. I didn't put the minus, this minus, that is to put a minus over here. So it will become minus okay. This is the answer to the question.